Have you ever pondered why thunderstorms aren't the only natural phenomena to produce lightning? What about volcanic eruptions? Welcome to a world where fire and electricity dance together in a spectacular yet perilous ballet. A world where lightning doesn't just crackle across stormy skies, but also illuminates the smoky plumes of erupting volcanoes. This is the captivating world of volcanic lightning, a phenomenon that leaves both scientists and enthusiasts in awe. Volcanic lightning is no rare spectacle. It occurs in nearly every explosive volcanic eruption. Yet, despite its frequency, it remains shrouded in mystery, sparking intrigue and curiosity in the minds of those who witness it. It's a phenomenon that raises a multitude of questions. How does a volcano, a symbol of raw, fiery power, also become a cradle for the electricity that we usually associate with thunderstorms? What causes the seemingly incongruous marriage of fire and lightning? The answer lies in the heart of a complex scientific process, a process that begins with the eruption of a volcano. When a volcano erupts, it doesn't just spew out lava, it also expels ash, rock fragments, and gases into the atmosphere, creating a turbulent environment. This turbulence, combined with the intense heat and the high-speed ejection of particles, sets the stage for a fascinating electrical spectacle. But the process doesn't stop there. It's in the midst of this chaos that a beautiful yet volatile relationship between volcanic eruptions and lightning is born. A relationship that not only illuminates the darkened skies with a brilliant light show, but also plays a crucial role in the creation of compounds essential for life. So, if the thought of a volcano spewing lightning sparks your curiosity, or if the fascinating blend of fire and electricity excites your scientific senses, you're in the right place. If you're intrigued by this striking phenomenon, buckle up as we delve into the science behind volcanic lightning. To comprehend volcanic lightning, we must first understand volcanic eruptions. Volcanic eruptions are fascinating yet terrifying natural phenomena that occur when there's a sudden release of energy and materials from beneath the Earth's crust. The real culprit behind this explosive event is magma, a molten or semi-molten substance that resides deep within the Earth's mantle. Under certain conditions, this magma begins to rise towards the surface. But why does it rise, you may ask? Well, it's all down to density. Magma is less dense than the surrounding rock, and just like oil in water, it naturally wants to rise upwards. As the magma ascends, pressure decreases and the gases dissolved within it start to form bubbles. Imagine shaking a soda can and then opening it. That's pretty much what's happening underground. This buildup of gas pressure eventually becomes too much for the overlying rocks to contain, and then, with a blast that can be heard miles away, the volcano erupts. Magma, now called lava, when it reaches the surface, along with a cocktail of gases and ash, is ejected into the atmosphere. This ejection of materials creates a volcanic plume, a towering column that can reach heights of over 10 miles. The ash within these plumes is key to our story, as it sets the stage for the formation of lightning. But that's a topic for our next scene. Volcanoes are complex and multifaceted, and each eruption is unique. They can be slow and diffusive, with lava gently flowing down the sides, or they can be explosive and cataclysmic, like a shaken soda can, releasing pent-up energy in one dramatic event. Regardless of how they erupt, one thing's for sure: volcanoes are an incredible display of the Earth's power, a reminder that our planet is a living, breathing entity. Now that we've understood the basics of volcanic eruptions, let's move on to the electrifying part. Now, how does a volcanic eruption, a fiery spectacle in itself, give birth to something as electric as lightning? Well, let's dive right into it. When a volcano erupts, it's not just molten rock that's thrust into the sky. A volcanic eruption is a cataclysmic event that spews out a cocktail of ash, gases, and rock fragments. This eruption creates a cloud of debris that rises thousands of feet into the atmosphere. Within this chaotic cloud, the stage is set for an electrifying performance. Now imagine the scene within this cloud. Countless particles of ash and gas, all in a state of turmoil, being thrown together in a violent dance. As these particles collide with each other, something interesting happens. These collisions can strip electrons from the atoms, creating charged particles. This process is known as charge separation. In a nutshell, when the ash particles collide, they don't just bounce off each other. Some particles gain extra electrons, becoming negatively charged, while others lose electrons and become positively charged. This creates a sort of electrical imbalance within the cloud. We've got areas with an excess of negative charges and areas with an excess of positive charges. And here's where Mother Nature's love for balance comes into play. Lightning is essentially nature's way of restoring electrical balance. When the charge separation becomes too great, the atmosphere can't resist the flow of electricity. And so a lightning bolt is born, streaking across the sky, a brilliant flash in the midst of the volcanic chaos. The birth of lightning in a volcano is an incredible example of how, even in the midst of nature's most destructive events, there are processes underway that contribute to the incredible complexity and beauty of our planet. So, volcanic lightning isn't as mysterious as it first appears, but how does it involve nitrogen molecules? We'll delve into that in the next scene. Stay tuned. Nitrogen is all around us, making up about 78% of the Earth's atmosphere. So, how does it fit into our electrifying story? Well, let's dive in. Nitrogen, a seemingly unassuming element, plays a significant role in the spectacle of volcanic lightning. You see, the extreme heat and energy generated during a volcanic eruption are powerful enough to split nitrogen molecules in the air. Now, to get a clearer picture, imagine two nitrogen atoms bonded together, forming a nitrogen molecule. This bond is incredibly strong but not unbreakable. During a volcanic eruption, the intense energy generated by lightning strikes can break apart these nitrogen molecules, allowing the individual nitrogen atoms to roam freely. But these nitrogen atoms aren't solitary for long. They are incredibly reactive and eager to form new bonds. With the volcanic eruption providing a rich cocktail of other elements, the nitrogen atoms find plenty of bonding opportunities. They can react with oxygen to form nitrogen oxides, or with hydrogen to form ammonia. These compounds, often referred to as reactive nitrogen, serve as vital nutrients for living organisms. They are a crucial part of the nitrogen cycle, a process that ensures the continuous supply of this essential nutrient to all life forms on Earth. So, in essence, the lightning produced during a volcanic eruption isn't just a spectacular light show, it's a catalyst for a chain of chemical reactions that convert nitrogen, a major component of our atmosphere, into a form that can be used by living organisms. From the heart of a volcano, through the flash of lightning, to the nitrogen cycle that sustains life, this is an incredible journey of transformation. And nitrogen molecules, despite their seeming insignificance, play a pivotal role in this journey. And there you have it, a chain reaction that starts with a volcanic eruption and ends with nitrogen molecules being split. Let's summarize the electrifying journey we've just embarked on. We began our exploration with the spectacular phenomenon of volcanic lightning. This dazzling display of nature's power is not just a spectacle to behold, but a complex scientific process. The ash, rock, and ice particles ejected during volcanic eruptions collide with each other, creating static charges. When the charges become too great, they discharge as lightning, illuminating the volcanic plume with a brilliant display of electric power. Then, we dove deep into the fiery heart of the Earth to understand volcanic eruptions. These dramatic events occur when there is an increase in pressure within a volcano due to the accumulation of magma. The magma, containing gases and molten rock, rises to the surface, resulting in an eruption. This release can be quiet, oozing lava slowly, or explosive, blasting out ash and rocks. Our journey took us further into the heart of the storm, exploring the birth of lightning in a volcano. The intense heat of the eruption causes ice particles in the volcanic plume to collide and generate static charges. These charges then separate, with the lighter, positively charged particles rising to the top of the plume and the heavier, negatively charged particles sinking. Once the charge separation becomes too great, a lightning bolt is born. Finally, we delved into the pivotal role of nitrogen molecules. When struck by lightning, the nitrogen molecules in the air split, allowing the nitrogen atoms to react with other elements. These reactions form compounds that are essential for life. Nitrogen in this usable form is a vital nutrient for plants and is an integral part of the proteins and DNA in all living organisms. Next time you witness the fiery spectacle of a volcanic eruption, remember the electrifying science behind it and the crucial role it plays in nature's grand scheme.